This is lecture 2 on sets, in the topic of pure mathematics and finite group theory at junior senior level, and the first author of the text, which is this one. It's in the Teach Yourself series called Mathematical Groups. Lecture 2, and the theme is sets. Now, the main topic is finite groups, and groups are a special case of sets. So it's probably a good idea to have a basic notions of what sets are. So that's what this lecture is all about. What are sets? So, how to define a set? Well, the notion of set is pretty basic in mathematics. So it's one of those things that you almost intuitively understand, and you don't really need to define too closely, because in giving a definition you always have to use some other concept, and then if you ask for the definition of that other concept, you can go on an infinite regress. So starting at the concept of set is pretty well the starting line. So intuitively, what is a set? Well, it's just a collection of things. Now that's pretty vague, so I'll give you a couple of simple examples. The set of chairs in this room, the set of apples on my living room table, the set of people in this apartment, yeah, that kind of thing. Okay, and the members of that set also have another name. They can also be called elements. So these two terms, elements and members of sets, two commonly used. In terms of notation, a set is often represented by a capital letter, Roman letters, so like capital A. And so this little a here would represent a member or an element of the set. And this epsilon, that's the fifth letter, like the E, the epsilon, fifth letter of the Greek alphabet, it means belongs to. So if you see this, just think belongs to. So little a belongs to big A means that this element, this member, little a, belongs to the set A. Now you can describe a set in two basic ways. One is just to give the complete list. For example, now you specify a set by left and right wiggly brackets. So if you see this bracket pair, you know you're talking about a set. So I can just list, for example, say the set of the first three members of the natural numbers. In other words, 1, 2, 3. Now I could just list them. 1, 2, 3. So that's one way of specifying a set. It's just to give a list. Another way is to give a description. For example, the set of x's, and then a colon, and that colon you read as such that, or having the property that. So let's say x is prime. Prime number. Okay? So this is the second way of specifying a set. You give a property or properties that these elements have to satisfy. So this set here is the set of all prime numbers. Now your specification, whether you give a list or a description, it has to be clear, right? So that you know if a particular candidate element is an element or not. Now in the problem-solving section towards the end of this lecture, we'll go into that in a little bit more detail. All right. Here are some very common sets used in number theory in pure math. So I'll go through some of these quickly. So capital Z, or if you're English, Z. It's the standard symbol for the set of all integers. So Z by definition, if I have 3 bars like this, I'm defining something. So Z is the set of all integers, so positive or negative integers. So 0 plus or minus 1, plus or minus 2, with a comma, plus or minus 3, and so on. Okay, so Z or Z. N is the natural, it's the set of natural numbers, the counting numbers, like 1, 2, 3, and so on. So in a sense I could use Z, I could say N, by definition, is Z plus, and the plus here means the positive integers. So starting 1, 2, 3, so that would be the set, 1, 2, 3, the counting numbers. These counting numbers are usually just referred to as the natural numbers, N for natural. The Z, where does that come from? Why Z? Well, it comes from German language. The German word for number is Zahl. Right, so they've taken the Z from this German word meaning number. I speak German, by the way, after living 30 odd years in Europe. Okay, R, what's R? I'll go through these fairly fast now. R is the set of real numbers. Now, I assume you know what a real number is. So the set of all of them, so infinite, uncountable set of numbers, that's R. C is the set of complex numbers. So that makes R a subset, and I'll talk a bit about that later. So R is a subset of C. C is a set of all complex numbers. R plus is the set of positive real numbers. So 0 is not a member of this set. Okay. But negative reals. Okay, this one. R star. This with a superfix here. The star means non-zero. So this means all real numbers except 0. Okay? And similarly, C star is all complex numbers except 0. Now Q is the set of all rational numbers. What's that? Make a bit of space here. So a rational number is defined as it's the set of all numbers of this form such that A and B belong to, let's say the natural numbers. Well, no, let's say Z, because you have negatives. And a second condition, that B is not 0. Now you can't divide by 0. So that's the set of the rationals, as they're called, Q. Q is the usual symbol for the rationals. And Q star would be where A is forbidden. Right? So these would be the non-zero rationals. Okay. If you have two sets like this, if 1, 2, 3, and you have another set that's 2, 3, 1. They're the same set. Okay, so set by definition is order independent. Okay, so it doesn't matter if you rearrange the order of the elements of the members of the set; it's the same set. Okay, so and repeats, like if I put another 1 in here. That is, repeats don't count. So A set is a collection of distinct or different elements. So if you have repeats, it doesn't matter. You just throw out the repeats and just leave with one of them. Okay, so 1, 2, 3, 1 is just the same as 1, 2, 3. Okay, a subset. What's a subset? Well, just common sense says it's like a small, usually smaller part of the set, with less elements, and all of the well, I'll do it in terms of a so-called Venn diagram. In fact, this one. So let your set, which you usually represent as by a capital letter, and the dots or points inside this oval or circle, they represent the elements. Now, let's call this set B. Now, if all the elements in B are in A, I'll repeat that, if all the elements of B in A are also members of A, then B is defined to be a subset of A. So let me, so for all, now you're familiar with this symbol? It looks like a capital V with a sort of wiggle like this. So this symbol means for all, or for every. So for all x belonging to B, x also belongs to A. Okay? If that's true for all your x, then, well, by definition, then B is a subset of A. Now, so the simple first subset is it sort of looks it's like a stretched C, capital C. So think of handlebars, like handlebars on a bicycle, right? So if you're wondering which is the bigger set and which is the smaller one, this is the way I remember it, a kind of mnemonic, like a trick to remember things. A is the bigger set, right? So in a sense, A is the boss of B. A